University, Montreal. I'm an associate professor of digital construction. I'm also associate dean of research and innovation at Ginacodi School of Engineering and Computer Science. Before I start, big thanks to the sponsors of the project, Creo Solution and their in-house tech Storia are the major industry partners who made this study available. It's still an ongoing study. And also MyTax and CERC provided the funding for it. I also wanted to emphasize, like, this is an ongoing work. It's IFC based, but what I'm presenting here today is not IFC. So the work is managed by my postdoc, Farzaneh, and my master's student, Limon, whom I'm presenting on behalf of. And what I'm presenting here is a Revit workflow of what we're, of a bigger work that is ongoing on IFC based. Why Revit? Because North America is highly dominated by Revit. So we went to many partners or potential partners, knock on the door and showed them amazing works that we do with IFC, with all the GraphDB and the knowledge graphs and everything. And they were like, great, but we don't have IFC. Can you do something with Revit? And Revit is not BIM, is like back to square zero. Anyways, so with that, and also the second heads up before I start, I'm not presenting in this presentation how to reach high accuracies. I want to actually, on the other hand, I want to show how and when things can go wrong. So let's go into it. The major, like this work is on, maybe I should have started by the title, semantic mapping of requests for information, RFI, I'm going to refer to BIM elements with LLMs. And well, RFIs, as we know, are, or requests for information, are formal procedures to facilitate the resolution of design ambiguities mostly, or when there are site discrepancies. Very simple process on the face of it. There's an issue, there's a question, the initiator initiates that, sends it to consultant or the design team, somebody coordinates that, gets the response, and once it's done, basically it's closed out. Very simple and easy process. So why is it of importance? Because of the impacts that it can have. RFIs actually slow down the process majorly. I'm going to show shocking numbers in a second. And also they can affect negatively the profit of the project. So that's why they are serious. Also, it's not uncommon in the litigation and basically claims to frequently referring to RFIs. Most important than all of the things on this slide, RFI is usually part of other processes or initiate other processes. Any change order or change directives typically start with an RFI. And with that reason, we looked into this very simple, linear, and happy process. Initiate, coordinate, respond, consolidate, bye-bye. So this is the way the process is designed. And this is the way it works in practice. So it never ever works like that. It's that the spaghetti has a lot of like rework and receiving false information, it's receiving things that are not related to what's supposed to do, and so on and so forth. So I won't gonna bore you with this. However, this is the reality, and the reason for that has different aspects, starting with the RFIs themselves. They are in most cases very vague. They are hard basically to even sometimes to read by a human who has the knowledge of the project and realize what they say in the first shot. The digitalization is not, in many cases, surprisingly enough, is not there. Some of the contractors in the interviews were talking about, yeah, we do digitalize. All the RFIs go through emails. Thank you very much. That's not digitalization the way we know it. It's not standard across the projects, even in the same company, surprisingly enough. I have no idea why. And lastly, maybe that's why. They're very good tools for abuse. So basically for personal interest or any type of, dirty games to be played, RFIs are good, basically, carpets to put everything under them. So with that, and specifically because the common denominator all of those is more time and more delay. The study showed like it takes 17 person-hours on average to process an RFI. The study is a little bit old, it's 2000. Of course, these days things are easier. Many projects have digital basic information. It's easier to query data in general. However, I won't be shocked if the number is still double digit, and it really shouldn't take that much for people to receive and like request, file it, get the answer, done. It shouldn't take 17. The process is still to date very time consuming, error prone, and of course, inconsistencies happen from one iteration to the other one. So our solution is very easy conceptually and in an ideal world. So the idea is to automatically link the RFI text into the BIM through LLMs. Simple as that. The problem is the RFI and the BIM do not speak the same language. On the one hand, we have the RFI, which is the unstructured, basically human language. On the other one, we have the BIM data, which is very well structured. We have the semantics through basically schema and so on and so forth. I don't think I should spend much time. The previous presenters did a fantastic job in terms of realizing what the issue is and how LLM can be a very good basically tool to bridge this gap. Looking back at the previous works, BIM is typically used heavily for leaning the process, for basically constructability analysis, for design coordination. All of these are great tools to prevent more and more RFIs from generation. But once they're there, so these cannot help that much. On the other hand, the LLMs are mostly on identifying recurring issues, the main themes in documents, and classify the problematic issues. When it comes to bridging the two, the previous works are mostly focusing on model querying, conversational basically applications. Fantastic presentations by previous presenters on that. A lot of work on, of course, parametric design and generative design, and some work on compliance checking. I think there was also nice presentations from that in today's work. However, when it comes to RFIs in specific, and in the next few slides, I show what's the peculiarities about RFIs, there's not much out there. So the main objective is to create that link between the text and the BIM and identify which element or elements are being addressed by RFI. So once again, the major focus of this part of the study was, give me the RFI, I parse it, and I give you the Revit elements that are being discussed or being affected by this RFI. Here is the workflow. There are three major parts. The top left is showing how we parse BIM. Top right, how we parse the RFI. And in the bottom, we show the semantic matching algorithm that matches the two. And finally, we have the human on the loop to do the validation, iteration after iteration. So let's go into each of these and see how we do what we do. Starting with basically the BIM part, the Revit, we created a simple Revit plugin. Probably my math assistant hates me if he hears that it's not simple. It's simple in the context of it, but practically it's not that simple. But basically we expose the Revit elements through HTTP endpoints. And then we basically embed for each and every BIM element at least six different categories of metadata that you see here. And we basically cache these embeddings, and they're there. It's a little bit time consuming, but it's done only once throughout the life of the project, so no problem there. Then moving on to how we parse the RFI. We do parse the RFI and again create embedding for RFIs. The exact, we use prompt. There should be better ways, but we do a specific prompt for these 4 Qs, and it works very well. We didn't have any issues with the prompt, at least for that. What's the primary elements? What's the element type? Any locational context or any proxies that we can know where the element or whatever query in the RFI is referring to. And the fourth one is some important keywords. And these two embeddings then are used in a semantic vector space to calculate the matching between each element and the RFI that we have at hand through this procedure. So the semantic basically matching has 5 stages. The first one is if there is a basically direct match, it's direct ID match. If the basically GUID or UUID of elements happen to be in the RFIs, off the records, we analyze more than thousands, of course, tens of thousands of RFIs, and it only happened twice that somebody is referring to that UUID after being questioned by the designer. So if that's the case, done, and we won't go into the next of the stages. However, in most of the cases, we go into the other stages. The second stage is a spatial context match. Do I have any floor, levels, grid lines, any type of room numbers, and so on and so forth, so that I know where I should look at. The system context match, that's mostly for MEPs to match to see that system type and classification do match. The fourth one is, like, after having those, we create an initial shortlist through a basically lexical match. That looks into four things: the lexical similarity between the text in the RFI and the element's description. Let's put a pin on that because I have to come back into it and say why we should lower down the weight of it. It tends to create a lot of elements. Of course, if the RFI is talking about concrete, blah, blah, then anything with a concrete will be matched, and that's not what we want. So that's why we lowered the weight on that. And then the keyword grounding on the boosting on those keywords that were cached, were basically embedded. Dimension match is also interesting. Actually, we started with the comprehensive list. We ended up with these 3+1 to be the major ones. The dimension match is basically talking about the 4x6 lumber or such and such HSS type of sections that takes us there. And finally, we penalize for category matches. Things such as basically analytical model explanations or material type and so on and so forth. Those have to also be, the weight of them should be lowered so that we don't get a huge short list of elements. I'm going to move on a bit faster. We do the semantic mapping. We identify what elements goes with what. And if I can take 30 more seconds to show the results. We tested this on basically an pure experimental environment and on an actual project. On the experimental one, we created manually 10 RFIs, and the work could find 8 out of 10. For 8 out of 10, we could find the element, the entity. And for 9 out of 10, if we could not find the entity, we could find the category or family. And I wish I could say bye-bye here and go enjoy my rest of the time. However, when we go into actual test, it was terrible. So out of the top number is not 10, it should be 74. Out of the 74 RFIs that could have been basically relevant, only 3 without intent and 4 with intent could be identified. This is terrible, right? So we had to do more and more, and we could actually bring up those numbers into 19 and 52, looking at different configurations of LLM and changing basically that semantic mapping. However, the major question was where things go wrong and why these happen. I had more to show on case by case of why these happens, 6 items, but I don't have time. I would be happy to go through them if there's any question, but maybe I should leave here by number 1. Of course, RFIs are ambiguous. Again, these are very short and basically cramped texts. It's easy for them to go wrong. 2, many of them refer to attachments, including drawings and so on, which we intentionally excluded from this. We wanted to know only text alone. With those, the number is more than 92%. So in most of the cases, if there is a drawing, with a very good chance you can find where it's referring to. And lastly, the inconsistent BIM data. So I start with 2 messages. BIM LLM integration does need to be looked at as a BIM use. Model preparation is necessary. You cannot take the models that we receive from the design. Model preparation is necessary. What's the protocol to be determined? This is number 1 on that. And number 2, let's not make an assumption that LLM will fix things. LLM cannot fix things. Some of the colleagues did mention when it comes to engineering context, it never ever, like LLM alone cannot understand the context. Thank you very much for your attention, and I stop here.